Hello students, hello teacher. This is grade 7 mathematics lesson delivered by Addis Ababa City Administration Education Bureau. And I am Zuna Makonnen. So today we'll focus on Unit 1. Unit 1. Basic concepts of set. Basic concepts. Basic concepts of set. Today's lesson topic 1.2 Relation among sets. Relation among sets. Students, after this lesson, you are expected to, after this lesson, you are expected to describe relation among sets. Describe relation among sets such as equal sets, equivalent sets, subsets, and proper subsets. So now, let's continue the lesson. Now let's start from equal sets. Two sets A and B are said to be equal if and only if they have exactly same elements. So let me write the definition. Two sets A and B are said to be equal if and only if they have exactly the same element, the same element. So if they are equal symbolically, we can write using this symbol. If two sets are equal, we can write symbolically like this. A is equal with B. Now, let me give you example for this. Example. Identify whether the following sets are. Identify whether the following pair of sets sets are equal or not, are equal or not. Now the first one, set A is given to be 1, 2, and 3. Let's take another set. B is 3, 2, 1. Are these two sets equal? Let's see it together. Set A consists the elements 1, 2, and 3. And set B also contains the elements 3 to 1. Writing the order doesn't change the sets, therefore set A contains the elements 1 to 3, and set B also contains the same element. Therefore, these two sets are equal sets. Therefore, here set A and set B are equal sets. Now, let's continue to the second example. Let's take another set. Set C contains the elements A, B. And set D contains the elements 2 and 4. Are these two sets equal sets? I will give you 10 seconds for this question. Students, have you tried the question? Good. Now let's see the answer together. When we see these two sets, set C contains the element A and B, but set D contains another element, 2 and 4. So these two sets do not have exactly the same element. Therefore, they are not equal. Set C is not equal. Set C is not equal with set D. These two sets are not equal sets. Now, let me add one more example. Let's take this one. Assume set E contains the elements 1, 2, and 1. And set F contains the elements 1 and 2. Are these two sets equal sets? Please try this question. I'll give you 10 seconds for this. Students, have you tried the question? Very good. Now, let's see the answer together. Okay, as you can see here, set E contains the elements 1, 2, 1. Repeating the elements in set doesn't add additional element. Therefore, this means it's the same as, this set means the same as 1, 2. This set contains only 1 and 2. It contains 2 elements. And set F also contains 1 and 2. So these two sets have exactly the same element. Therefore, set E and F are equal sets. Therefore, the answer is set E is equal with set F. That's it. Now, let's proceed to the second concept about equivalent sets. Equivalent sets. Okay, let's define it first. Two sets are said to be equivalent if and only if they have equal number of elements. So let me write here. Two sets are said to be equivalent if and only if they have equal number of elements. If they have equal number of elements, the two sets are said to be equivalent. Now, let me give you example for this. Example. Identify whether the following pair of sets are equivalent or not. Equivalent or not. Okay. Set A contains the elements X, Y, Z, and set B contains the elements 4, 6, and 8. Are these two sets equivalent? Let's see the answer together. As you can see here, set A contains 3 elements, X, Y, and Z. It contains 3 elements. This set contains 3 elements. Again, when you count the number of elements of set B, it contains 3 elements, 4, 6, and 8. This also contains 3 elements. Since these two sets have equal number of elements, the two sets are said to be equivalent. Therefore, A and B are equivalent sets. Symbolically, we can write in this form. A and B are equivalent can be written as symbolically like this. The two sets A and B are equivalent. Now let's proceed to another example. B. Assume here set C contains the elements 6, 10, and set D contains the elements 1, 2, and 4. So, are these two sets C and D equivalent? I'll give you 10 seconds for this question to try. Very good. Have you tried the question? Now let's see the answer together. When we see set C, it has 2 elements, 6 and 10. Here we have 2 elements. When we count the number of elements of set D, it contains 1, 2, and 4. It contains 3 elements. The number of elements of set D is this 3. So when you see these two sets, they do not have equal number of elements. The number of elements of sets is 2. The number of elements of set D is 3. So they are not equivalent. Therefore, here, C and D are not, C and D are not equivalent. Are not equivalent sets. Okay, now one last example for this. See, assume here set E contains the elements 1, 2, 3. Again, set F contains the elements 1, 2, 3. Okay, I'll give you 10 seconds for this question for you to try. Students, have you tried the question? Very nice. Now let's see the answer together. When we see set E, it contains 3 elements, 1, 2, and 3. And when we see set F, it contains 3 elements, 1, 2, 3. They have equal number of elements. Therefore, these two sets are equivalent. So here, set E contains 3 elements. 3 elements. Again, set F contains 3 elements. Since they have equal number of elements, the two sets are equivalent. Therefore here, E and F are equivalent sets. They are equivalent sets. Okay, now here, what we have seen earlier, when we compare these two sets, not only equivalent, they are also equal. They have exactly the same element. The elements here are 1, 2, 3. And again here, the same element is there. Therefore, these two sets, in addition to equivalent, they are also equal. So, we can conclude one point here. All, note that, all equal sets are also equivalent sets. All equal sets are equivalent sets. Since if they are equal, they have identical the same element. They have the same element. So when you count the number of elements, also same. Therefore, if two sets are equal, they are equivalent. But the reverse is not true. If two sets are equivalent, they are not equal. But if two sets are equivalent, then they may not be equal. They may not be equal. They may not be equal. We can see this concept through example. If you take set A, if two sets, equal sets, assume set A contains A and B, set B also contains A and B. These two sets they are equal, they are also equivalent. So A and B are equal sets. A and B are equal sets. They are equal sets. They are also equivalent. Since the number of elements here is 2, again here is 2, A and B, A and B are also equivalent. If two sets equal, they are equivalent. Now, but equivalence does not imply equal sets. Let's see this for example. If you take set A contains the elements 1, 2, and set B contains the elements A, B, these two sets, they are equivalent. The number of elements here is 2. The number of elements in set B also 2. They have equal number of elements. They are equivalent. But they are not equal. They do not have identical elements. They are not equal. So, equivalent sets may not necessarily equal sets. But here you have to note that all equal sets are equivalent, but all equivalent sets are not equal sets. Now, let's proceed to another concept. Subset. Subsets. Okay, here, subsets. Let's define first what means. Set A is said to be a subset of B if and only if and only if all elements of set A are found in B. That's the definition. So A is said to be a subset of B if and only if all elements of set A are also found in set B. This is a definition. If A is subset of B, symbolically we write in this form. A is subset of B, symbolically written as like this. Okay? Now, let's see example for this concept. Example. Suppose set A contains the elements 1 and 2. Set B contains the elements 1, 2, and 3. Set C contains no element, it's empty. And set D contains the elements 2, 1. So, identify whether the following are true or false. Identify whether the following are true or false. True or false. Question A. Set A is subset of set B. Is this statement true or false? Now let's see the answer first. This. The meaning of this one is all elements that are found in A are also found in B. Let's see the sets. Set A contains the elements 1 and 2 of B. Set B contains the elements 1, 2, and 3. Are all these elements found in this set? Yes. 1 is found here, 2 is also found here. All elements of this set are also found there. Therefore, A is a subset of B is true statement. This one is it is true. This one is it is true. Now let's proceed to second example. Okay. A is a subset of D. Please try this question. I'll give you 10 seconds. Okay, students, have you tried the question? Very nice. Now let's see the answer together. Here it says A is a subset of D. When you see the elements, set A contains the elements 1 and 2. Subset of D, D contains the elements 2 and 1. All elements found, the meaning as I said earlier, A subset of D means all elements here are found in D. Okay, all elements found here must found on second set. Okay, let's check it. Is 1 found? Yes, on the next set. Is 2 on second set? There is. So all sets here are also found in this set. Therefore, A is subset of D is a correct statement. So this one is true. Now let's see another example C. Let's see this one. B is a subset of A. Is this a true statement? I'll give you 10 seconds for this question. Students, have you to write the question? Very good. Now, let's see the answer together. Set B contains the elements 1, 2, and 3. 1, 2, and 3. Subset of set A contains the elements 1 and 2. Are all elements here found on second set? Let's check it. Is 1 found there? Yes. Is 2 found there? Yes. Is 3 found here? No. Because of this, all elements of these sets are not found on second set. Because of this, this is not true statement. B is not a subset of A. So this statement it is false. This statement it is false. Now, let me add one more. D C is a subset of D. Now, let's try this question. Let's see this question together. Is C subset of D? Which means set C has no element. Subset of set D contains 2 and 1. 2 and 1. Here we can check this statement in this form. Is there an element which is found in this set but not there? There is no element which is found here but not on second set. So this does not violate the definition. Because of this, empty set is a subset of this set. I'll repeat this statement again. Is there any set here which is not found there? When we check here, there is no set, there is no number which is found there. So, because of this, empty set is a subset of a second set. And we conclude any empty set is a subset of any set. So, let me write the conclusion here. Note. 1. A set is a subset of itself. A set is a subset of itself. If you take any set A, for example, if you take any set A, 1, 2, A is a subset of A is it is true statement. All elements in A are also found in A, so any set is a subset of itself. Again, the second concept, empty set is a subset of any set, since it does not violate the definition. So I can write like this: if set A is given, empty set is a subset of any set A, whether set A is empty or any other set. Therefore, empty set is a subset of any set. Now, let's proceed to the next concept, a proper subset. Proper subset. A is said to be a proper subset of B if and only if A is subset. A is a subset of B and B has at least one more element. I'll explain these definitions through example. First, let's just symbolical notation of A proper subset of B. A proper subset of B is, it is denoted by this symbol. It is denoted by this symbol, A proper subset of B. So the meaning of this statement means all elements of A found in B, and B must have at least one additional element. It may have one additional or two or more. That's the meaning. We'll see this concept through example. Okay, now let's see example. Suppose set A contains the elements, the letters A and B, and set B contains the letters A, B, C, and D, set C contains the elements A and B, and set D doesn't have an element. Now, let's identify whether the following statements are true or false. True or false. The first one, A, a proper subset of B. Let's check these statements together. A is a proper subset of B. Now, let's see the elements that are found in set A. Set A contains the elements A and B. A proper subset of set B contains the elements A, B, C, A, B, C, and D. Proper subset means all elements here are also found on second set, and the second set must have additional element. Let's see. All these two sets A and B are found on second set. In addition to that, it contains additional elements C and D. Therefore, this set is a proper subset of the second set. The statement is correct. This one, it is true. A is the proper subset of B. It's a true statement. Now, let's see another example. Take this one. Is A a proper subset of? Is A a proper subset of C? Is A proper subset of C? I'll give you 10 seconds for this question. Students, have you tried the question? Very good. Now let's see the answer together. Here it says set A is a proper subset of set C. Now let's see the elements that are found in set A. Set A contains the elements A and B. Is a proper subset of set C. Set C contains these two, A and B. Okay. The meaning of this one, proper subset, means all elements in this set are found in this second set. In addition to that, the second set must have at least one more additional element. When you see, all elements are found on second set, but the second set doesn't have additional element. Because of this statement is not true, or this set is not a proper subset of the second set. Therefore, this statement it's false. This statement is false. Okay, let's proceed to another example. Let's take this. Take this one. Set D is a proper subset of set A. This statement, is it true or false? I'll give you 10 seconds for this question. Students, have you tried the question? Very nice. Now let's see the answer together. So here, when you see set D, D has no element. It's empty. It's a proper subset of set A contains the two elements A and B. Okay, to check this, is empty set first. Is this empty set a subset of the second set? Yes, it is. We said earlier, empty set is a subset of any set. So after checking the subset, does this set has additional elements than the first set? Yeah, it has. It has more elements A and B than first set. So because of this set or empty set is a proper subset of a second set. So we conclude that this statement it is true statement. It is true statement. Now let's conclude, or let's take a note. Note 1. A set is not a proper subset of itself. A set is not a proper subset. Is not a proper subset. A set is not a proper subset of itself. For example, if you take this one, set A contains the elements 1 and 4. So if you say like this, A is a proper subset of A, this wrong. It's not a proper subset itself. Because set A contains 1, 4, set A contains 1, 4. This set has no more elements. Because of that, it's not correct. Therefore, this is a false statement. So a set is not a proper subset of itself. Again, here, empty set is, again, empty set is a proper subset of a proper subset of any other set. Empty set is a proper subset of any other set. Empty set cannot be a proper subset of empty set, but it is a proper subset of any other set. So here, if you take this one example, if you take set A empty, set B any other set, if you take any other set, 2, 4, A is this a proper subset of B, because we said empty set is a subset of any set, and second set has more elements than the first. Because of this is true statement. This one is a true statement. So you have to know that empty set is a proper subset of any other set, but empty set is not a proper subset of empty set itself. Which means if you have such statement, empty set is a proper subset of empty set, this one is a wrong statement. Because the second set has no more additional element. Because of this, empty set is not a proper subset of empty set is a wrong statement. This one is wrong. So this is it. Now, this is all about today's lesson. Just to summarize what we have seen today, let's see the main points. Summary. We started from equal sets. Two sets are said to be equal, written in this form, A and B are equal, if and only if A and B have identical elements. This is true. If and only if this is true, is true. If and only if and only if and only if A and B, A and B have identical elements. We have seen these equal sets. The second one is equivalent sets. Two sets are said to be equivalent if and only if they have equal number of elements. This is true, is true if and only if and only if they have equal number of elements. If they have equal number of elements. Equal number of elements. Say this one. And A is said to be subset of B. A is said to be subset of B if and only if all elements of set A are found in B. This is true if and only if all elements of set A, all elements of set A are also in B. And the last concept that we have seen today is a proper subset of B. A is a proper subset of B if and only if A is a subset of B, and B must have at least one more additional element, and B must have at least one more element. At least one more element. So this is a concept that we have seen today. So I will give you questions for you to try at home. Exercise. Identify whether the following statements are true or false. Identify whether the following statements are true or false. Okay, the first question. 2, 3 is equivalent to AB. Second question. 2, 4, 6 is equal with set A, B, C. Third, A, B, C is a subset of ABC. 4, 1, 2 is a proper subset of 1, 2, 3. Again, the last fifth question. 2, 8 is a proper subset of 2, 8. This is it. This is all about today's lesson. Please copy the questions and I'll give you 1 minute and try it, Tom. That's all about today's lesson. Until next lesson, goodbye.